Assuming you guys can hear me, eh?
Yes, sir.
Perfect. Just give me a moment. Just going to open up Chrome. Okay. Yeah. Let's hope it's all going to work out. All right. Let's begin. Welcome all. Welcome to Mathematics in 4. Yeah, it's I think it's a very soft um subject. It's fairly straightforward. And we're working as a team of 4 tutors, and so you get to at different modules, different tutors will come in. I believe I'm doing module 1 and a bit of module 2, and then the other tutors will come in. And of course, you belong to a particular group. It could be A, B, C, or D. And those are the students each tutor will be responsible for. But that being said, let's quickly move on. So the book we're going to be using is this book over here. Any book with a revised curriculum 2022 should suffice. But this is the one we've shared, works fairly well, it's fairly accurate. And yeah, these are the chapters. So it's 1. Okay, that's better. Okay, anyway, know that. Can you guys see my book? Module 1, determinants, complex numbers, trigonometry, functions and graphs, differential calculus, and integration. Very soft. Can we all see the book? Hello?
Yes, sir.
Yes, sir.
Okay, perfect. So let's quickly
Hello,
begin.
sir.
If you can't, probably refresh and then get back in. Let's begin with determinants.
Okay,
What
sir.
is determinants? Okay. So there's a lot for me to say with this, say. And just admit people in the lobby while I'm teaching. So I'll just put up this before I engage with all the other fun stuff. Are we all familiar what this is over here? This set of things. What do we typically call this coming from grade 12 or from high school? Can anyone tell me?
Simultaneous equations.
Exactly, simultaneous equations. Yes, it's an equation. That's also correct. Simultaneous equations, right? So just looking at this over here, how do we go about solving simultaneous equations? Can someone tell me?
Process of elimination.
Yes, that's one. There's another one. Talk to me, guys. Talk to me.
Substitution.
Substitution is another one. There is another alternative called, you can use the graphical method. Are you guys aware of that? Are you guys aware that you can use graphs to solve that as well? Yes or no?
No.
No, sir.
Okay, right. So you can also use graphs. So I just want to, we're going to spend a lot of time today. So let me quickly show you something interesting. Wait. I do want to show you where you could possibly use this. But let me just show you graphically how you could solve this, if you don't mind. So let me just unshare this guy, and then I'll reshare something called Excel. So by the way, if you want to become an engineer one day, one of the things you kind of have to master before you go into any of this design stuff is Excel. Can you guys see my Excel spreadsheet over there?
Yes. Yes,
Cool.
sir.
Yes, sir.
Yeah. So what I want to do now, I'm gonna choose one we're gonna solve eventually, and we're gonna compare those answers again. So let me just quickly scroll down and go find one that is solved in the textbook. Solution of equations. Yeah. Okay. Yeah. Here we go. So what I'm gonna do now, try to solve this graphically. Can I even remember how? I wonder if you guys are able to draw graphs on Excel. How do I do this now again? So those are my two equations there, right? Can you all see that? That too? Okay, so what I'll do here, I'll define my X value, my Y value. And I'll say equation 1, then equation 2. Let's quickly see if this is going to work. I'll start from -2, -1, -0. In fact, your Casio calculators can do this as well, but in a different way. So I'm trying to have a visual representation of what this is about. So copy all of these here. Some reason I feel like I got out to this. So what I'm doing, I'm typing the first equation in. 3 times x plus 4 times y. Okay, cool. Something is bothering me here. I need to put this in a different form. Okay, so I need to adjust this quickly because okay. You know what? Let me come back to this. Let me come back to this. I'll show you again. Let me come back to this. Let me just quickly move because I want to get to the good stuff and then I'll sketch it afterwards. So let me just move. Okay, cool. So what the main purpose of this chapter, right, is basically solving these two linear type equations. You've learned about elimination substitution. I'll show you the graphical as well. I'll do it while you guys are practicing. And then there's a new method now, right? And that's going to be called determinants, the method of determinants. And they typically call it Kramer's rule. I think Kramer developed it. I can't remember his name, not John Kramer. That's from Saul. So where this method is powerful is sometimes you might have 3 equations and 3 unknowns. So you can use substitution and elimination for this. However, it's super long. It's a very lengthy process. So what I typically show my students is using the substitution and elimination first, so that you get an appreciation for when you use determinants that is actually a bit quicker. All right. So, but I'm not going to do that now. I'm just going to follow with the actual content. So you can use these methods to solve this. Determinants can also solve 4 equations, 4 unknowns, 5 equations, 5 unknowns. Those cases do eventually come up depending on what you modeling or what design you're doing. So that's just letting you know. So the reason why we use determinants is because you don't always end up with only 3 equations. Let me see if I can quickly find this particular thing I had over here. So we're going to get to the fun stuff now. Don't worry. Cool. So like this is also part of both in civil engineering and both mechanical. And I don't know why the mechanical doesn't do it this way, but I'm sure we're all aware of trusses. Trusses are standard designs for bridges. I'm sure we've seen somewhere along these. We could also imagine this being in the top of the roof, right? So the house's structure, we would use something called a truss, okay? It's a combination of members in tension and compression. There's a few of them there, the Warren truss, Pratt truss, Howe truss, and then the Warren truss with verticals. So what I want to show you here, now I could have actually used that as well, is that when we want to find the forces within these members, right, we take a certain approach. We apply the first condition of equilibrium, and then we basically label all the forces, the reactions at the ends. And then what we do, we use a method called method of joints. And then we basically take the forces at each joint. So this is not part of maths, but I'm just kind of showing you what tends to happen, right? So you take equation each joint. So let me just go. Let's just find the reaction. The reactions are basically over there. All right, that's fine. And then we apply this method of joints at each node. Node 1, node 2, node 3, node 4, node 5. What I mean by node is by that particular piece. Let me just zoom here quickly. So when we do that, we end up having a few equations. Check this out. There's one equation over here, another equation over there. That's for node 1. Another equation over there, another equation, another equation, another equation. All these equations. So we have a few x's and y's or variables. Look, we have R1, F12, F13, F24, F34, F23. As you can see, there's a lot of variables, right? Then we have a system of linear equations, right? In this case, can you see we don't have only two, we have what's this, 9, right? Then we kind of set that up in a form where it looks like this. So this is all the coefficients attached to that. So here we have 9 equations, 9 unknowns, right? And we need a procedure on how to solve that. And the way to solve it, one of the ways is using determinants. You cannot do this via substitution. I'll show you one more, I wasn't going to do all of this, but okay, here we are. There's a lot you can do. Let me just go to John Bird, open it up. Can you guys see my stuff in front of you? Can you see it? Just checking. Perfect. I got that, CJ. I'll show you another example. If you have a circuit like this, right? Something called Kirchhoff's law. I believe you might learn about the electrotechniques in 4. You want to set up 2 equations for this, right? So the reason why this is important, what this kind of basically is in a practical sense is you might have one generator here and another generator here powering a certain load. Happens a lot, paralleling generators. And what you do, you apply some loads and you end up with 2 equations, 2 unknowns, which is essentially shown over, that's equation 1 and equation 2, right? 2 equations, 2 unknowns, we need a way to solve. Obviously, we can do substitution in this case. It's very easy, but I'm going to show you determinants. Going further, a circuit like this, right? The one on the what's this, the right? We have more equations. You have one equation over there, another equation over there, and another equation over there. So you have 3 equations, 3 unknowns. You need a way to solve that. Determinants will be your best friend. I'll show you another one, and this is now an AC circuit. You probably do this electrotechniques in 5. It's worthwhile knowing these things. Let me just find AC quickly. I don't see my AC stuff here now for some reason. Single phase. I don't think it's in this one, but you also have to you really have to bold. Yeah, I don't see my AC design here. The AC design part of it. You also need a big set of big set of equations to solve these circuits. Let me just quickly see if I can find that one. Let's try this one. I just want to see if I can find it. Second edition. I wonder if it's here. Doesn't seem like it's here. Okay, no, it's not on this one. But you're gonna need a big set of equations for this. So knowing this math is very useful. But anyway, I'll try to think of things as I teach you. Okay, so let's start unpacking what Kramer's rule is about, or determinants, right? Let me just say determinants. Okay, so let's start over here. I'm gonna go to my OneNote now. And I'm going to show you how we basically get what a determinant is. So I'm just going to share this. And I'll catch you. Can you just mute your mic, please, man? Okay, so imagine we had 2 linear equations, right? I'm assuming we all can see that over here. And what I'm going to do now, I'm going to use the process of elimination, okay, to get 2 equations. Can you please mute your mic? Whatever that is, okay. elimination. And I want to show you how we're going to get equations, how to solve x, and how to solve for y, right? Just bear with me. You'll see what I mean. So how do we approach this? So the first thing we want to do, we want to get with elimination. If you do recall, we want to eliminate one of these variables here, right? And then after before we do that, we need to multiply the first equation by a certain coefficient, and then the second one. So let me do it quickly. So if I want to eliminate variable x, so we will eliminate variable. Let's eliminate first y, right? For me to eliminate y, I got to times all of this by b2. It's going to sound a bit theoretical, but you'll pick up. So if I times everything by b2, we have a1, b2, what is it? X plus b1, b2, y plus c1, b2 equals 0. But okay, that's fine. And then what we want to do on this side, if you want to eliminate y, we want to times this by b1. The reason why I'm doing that, so remember, we want to eliminate this guy over here, that variable. So this will be a1, sorry, that's a2, b1 times x plus b2, b1 times y plus c1 times b1. And we make that equal to 0. So if you remember, with elimination, we can subtract the two equations. And the reason why we're subtracting is that this minus that should give us 0. Okay? I hope everyone's following. So you're going to say that minus that. That's going to be a1 b2x minus a2 b2x. That minus that, right, gives us what? Nothing, right?
0.
Yeah, exactly. In a second. Let's just give me, yeah, okay, cool. And then we're gonna have C1, the C1 B2 minus that, and that'll give us can we say plus C1 B2, that's minus what is it? C1 B1 equals 0. Did everyone follow me till now? If not, please let me know. I'll keep it a minute open. Questions, excuse me. Yeah. I'm assuming we're on the same page here, right? So what we're going to do now, we're going to solve for x here, right? We're going to put x as the variable we want. So the first thing we do, we carry over all of these ones. So that's C1, B1 divided by C1, my bad, C1, B1 minus C1, B2. What we do here on this side, we take x as a common factor. That's A1, B2 minus A2, B1, right? And that's going to be equal, because what I did here, I took that over to that side. I took this over to that side. What we then have to do is obviously, if you want x on its own, we have C1 B1 minus C1 B2, and we're going to divide it out by A1 B2 minus A2 B1. This over here, right here, is basically a formula to determine any x value for two linear equations. That's what we've done. It's a general thing. So what I mean by that, if I take this one over here, and I want to know its x value, right? All I got to do is type those coefficients in and get the x value. I'm assuming all the coefficients are. So what I'd like you guys to do, use this set of equations given here and tell me what the x value is. I'm assuming we know that A1, B1, C1, they are the coefficients, right? I'm assuming that terminology is sorted out. So can we use this equation over here, right, to find the x value? And remember, we haven't solved anything. We just developed an equation to find an x value for two linear equations. Are we all on the same page? You can say yes.
Yes.
Perfect. So let me just set it up for you, right? You read to me. So what is my A1 coefficient? Using this over here. What's A1? Talk to me, guys.
3.
Yes. What is my B1? That's times.
4.
4.
Perfect. Minus, I'm just following that. What's C1?
Negative 13.
Negative.
Cool. Perfect. I like it. B2.
B2 is negative 5.
Perfect. And then A1 again is going to be 3, right? What's B2?
Oh, B2. Oh, it's negative.
Perfect. And we're going to say minus. What is A2? 2, right?
Yes.
And then what is my B1?
Negative 1.
Perfect. No, it's not, yeah, not negative 1. It's just, oh, what's B? What's B what?
Oh.
It's a B1, right? B1. It's negative
B1
5.
is
4.
Oh, 4.
Yes,
My bad. My bad.
four.
Yeah, there we go. Okay, cool. So I'll put 2 brackets here. I'm assuming you guys can do this in a calculator. And you want to put this in a calculator just like this. You want to have brackets there. Okay. Give me my X value. I'm warming up to determinants. You'll see. This is a determinant. Wow, yeah. Times root spreadsheet. Okay, cool.
It's minus 1.
Minus 1, eh? Cool. Right. Do we all get minus 1? Can we confirm that we all got minus 1?
Come again.
Excuse me?
Please say come again. What do you get negative 1?
What did you get?
Yes.
What did you get?
No, negative 1 confirmed.
What did you get? Please
Sir,
tell me. Guys, move.
yes,
What do
sir.
you guys get?
Sorry, sir, I
well-
gave you the wrong answer.
Mulke, Sabelo,
Hi, sir.
talk to me.
So I just have a question. The B1 isn't that negative?
Brent, I
Negative
don't know if you're
4.
saying something.
Hi, sir.
Mr.
Can you hear me?
Kanya in the Pile.
Can you hear me, sir?
What did you guys get?
Sir, can you hear me? Hello? Hello?
Yeah, we can hear you, Brent. We can hear you.
Okay. My question is, guys, you see by
X shouldn't
B1 isn't
be
that a
negative
negative
1.
4
What did you guys
instead
get
of
for X?
instead of
Negative 1
positive
is not
4?
probably correct, eh?
Sorry,
Negative
sir.
I'll just remove it.
3.35.
I got negative 3,348.
Brent, you're talking, but I can't. Are you talking?
Yeah, sir. Can you
Oh,
hear
my
me?
bad. I can hear you. Yes.
Sir, my question is, sir, the B1 isn't that supposed to be a negative 4?
Let me just check. Where am I? This B1 over here. That B1
Yes,
over
sir.
there.
Yeah, both of that, yes. Isn't that supposed to be -4?
Nah, it's definitely positive 4. You can see B1
Okay.
is there. Can you see
Oh,
that?
sorry. I'm referring to the one on top. Sorry, for Kramer's rule.
Okay.
Yeah,
Oh,
sorry.
I see it on. Yeah.
Uh,
No, this is in standard form here.
okay, sir. So you
Okay.
must first make it in standard form before you can.
Yes. Very
Okay,
good
thank you
question. I
for
was
that,
waiting
sir.
for this. There was something
Thank,
else as well with
thank you for
this as
that, sir.
well. Um, even this over here, that also should have been in standard form. So what did we get over here?
The answer is -3,35.
It shouldn't be like decimals. So let me come back here. So what we first do with this one over here, right? And this is what I'm looking for, is that you want to put this equation in standard form. So that'll be 3x4y minus 13 equals 0. 2x minus 1 equals 0. So you want to put it in the same form stipulated over here, all right? So if that is the case, these values are going to have to change over here, all right? So let me just quickly do that. Very important is the form, and I'm glad someone picked it up. And then -1. Why don't I have a -1 here? Where's my? Oh, I don't. It's eliminated. Is C2 eliminated here? Ah, guys, come on, man. I made a mistake. That's C2. Can you please mute your mic? Okay, yeah, there we go. I made a mistake there. So that's C2. That's going to be C2. That's going to be, what is this? This is C2 over here. The guys on top, that's C2. So we got to adjust this, man. That's my bad. So C2 will be what? -1. There we go. We can try it now. I believe everything else is still the same. Let me just check. Where is my C2? Do I have a C1? It's
Just spell it with me.
guys, my handwriting child me. Okay, here we go. So that's C1 over here. Let me just eliminate that. That's not A. That's C1. So remember over here, I'm carrying over this to that side, which is this, and then that to that side. There we go. Now we're on the same page. Here we go. So this is C1 should be ought to be -13. Try it now. Yeah. Tough. Okay, there we go. Just check everything, right? C1 -13, that's correct. B1 is 4, that's fine. Minus C2 is -1. Then we have -5, which is going to be B2, that's correct. I think that's good now. Yeah. So check what you get now.
2,48.
No, man. What are we doing wrong? It cannot be like that, man. Is my stuff out here somewhere? It should be exactly 3, I think. I'm pretty sure. Let me just verify here. B1, C1, right? B2. Let me check here. Wow. Okay. That comes over C2 B1, right? C2 B1. Ah, man, come on, guys. Oh, long day, no? So this comes over to that side. This comes over to this side over here, right? That's going to be C1 B2, right? And then let me do it like this. Let me repurpose this, guys. Apologies, man. Let me come back here. So this comes over to that side. So that's going to be C2 B1. That's the first thing. So that's C2 B1. This comes over to that side, and that's minus C1 B2. So in this case, this should be C1 B2. There we go. Okay, cool. So in this case, on top, you should have C1. C1 in this case here is negative 13. Man. Cool. And then C2 in this case is negative 1. Okay, it's still B1, eh? B1 is okay. Try it now.
3.
3, right?
Yeah.
You guys get it?
3.
Yeah, should be 3. Okay. So, if you got 3 answers correct, perfect. What we do as well, we can also do exactly the same for the Y via process of elimination. Okay, and I'll just put that equation up for you there. That was a stretch, but it was a necessary stretch. It's fine. So what you can do for Y, you can actually get Y as well. So to get this equation, we eliminate X, and then we get that one. So what I'd like you to do for me now, using the same set of equations, I want you to find Y for me quickly. Okay? Just find Y for me, using the same values. Tell me what you get. Talk to me.
1.
Perfect. Is it clean one or is it no negative one?
Just 1.
Okay. Are you sure about that?
I also get 1.
Okay. Let's have a look. Not sure. Could be right. Yeah, the odds is definitely 1. Perfect. Okay. Yeah. Colleagues, if you all get 1. If you
Yes,
all get
yes,
1.
yes.
Yes, sir.
Yes,
Yes.
confirmed.
Okay. Perfect. And we're all aware, right? If we substitute X and Y back into these equations, right? It should give us the answer on the left-hand side of 0. Do we all understand the concept of simultaneous equations before I move on? If I put 3 over here and I put 1 in there, I should get an answer of 13. Do we all understand that? That's how you know whether you're going wrong or right with these things.
Yes, yes, understood. When you're doing the test, left
Yes.
must be equal to the right. Yeah.
Okay, perfect, right? Very important concept because you're going to need it also for 2 by 2 and 3 by 3, right? You always know when you're going wrong with these things. That being said, if I look at my equation X and my equation Y, what do you notice what is similar between the two? Please tell me.
They are both positive in the
No,
sign.
not that. Look at the terms, the numerator and denominator. That's also good.
They
Yeah.
flip.
Excuse me,
The numerator and denominator are flip.
you're saying? You're a bit faint.
The numerator and denominator are flipped.
Or flipped. Are you sure about that? Look
Yeah.
properly. Look properly. Check properly.
Is it because of uneven numbers or what?
No, I'll just tell you.
Sir,
What's the
Yes.
question again, sir?
what is the thing
Denominator.
called underneath oh, my English is not very good. That the A1 B2 minus A2 B1 is the same on both sides.
Yes, that's what I'm looking for. That there is exactly the same.
What is it called, sir? The denominator or what?
You mean you mean the numerator? I'm coming to what's called now. Don't worry. The numerator
Okay.
and denominator.
Oh, denominator. Okay.
Yeah, there we go. Yeah. Okay, the top and the bottom of a. Okay, cool. So what we realize is that that bottom part is the same, right? So instead of us writing it out in this form, we write it out in this new form. And the form is like this, right? I'm leading into something what we call a determinant now, right? So instead of us writing it out like A1, B1, you'll just say X equals, you put this two lines, or you call it a matrix, square matrix, okay, just something like that. And I will put the coefficients in order, B1, B2, I'll put, what's this one? C1 and C2. And what, okay, that's fine. And then I'll do the same here. I have A1, A2, right? And then I have, what's it, B1 and B2. Okay. So what this represents, right? Let me show you. This thing here is called, okay, not yet. Okay, so then what we do is, what this is basically it's B1, say B1 times C2 minus B2 times C1, right? Which is exactly the same there on top. We do that same thing at the bottom. And this will be over here. This is equal to A1 times B2 minus A2 times B2. What I just did now, or B1, sorry. What I just did now was take the determinant of that. What this is over here is called a determinant. Are you guys with me? Someone called a determinant. You could have called it anything else, but they called it determinant for whatever reason. I'm not sure of. It determines something, obviously. So to find a determinant, this is when they say find the determinant, right? They're saying do that thing. So let me just quickly show you one example, and I want you to find the determinant for me. Let me quickly go through this. We're going through step by step. Don't worry. So I'm gonna come here. So let's find the determinant. So what's key of determinant? I'll say it again. You'll take this guy, that element times that, minus, right? Let me just put the minus black, minus the two blue ones. So what you're going to say is minus 4 times 1, which is the red guys. Then you put the minus sign, and you're going to say 2 times 3, right? Oh, that's the blue. And if you do this, you should get, my bad. You should get negative 4 minus negative 6.
Can you
Am I
please
right?
share the screen, meneer?
Negative 4 minus negative 6 is negative 10. You probably have to refresh. What can you guys see? Some guys think people can see my writing.
Please share the screen.
You must refresh. You must leave and come back to
We
you.
can see.
Okay.
No, sir, I can see everything.
Yeah. So do you see what I did there? Negative 4 times 1 minus 2 times negative 3. That's negative 10. We just took a determinant. That's what they mean, take a determinant. Are we all on the same page there?
Yes, we're still
Yes,
good.
sir.
Okay, so what I want you to do for me now, do number 2 and do number 3. Give me the determinant of that square matrix over here. This is actually called a square matrix. Let's just call it a 2 by 2 matrix. Let's call it a 2 by 2 matrix. What I mean by this is, anyway, 2 columns, 2 rows. I'm assuming, yeah, 2 by 2.
Sir,
Yes, brother.
can I ask a question, sir?
You sound you very far. I can
Can I
barely
ask a
hear you.
question?
Yes. Go for it.
So they can by finals, will they ask us to use one of the two methods or only the one?
Just determinants.
Okay, just the Kramer's law. That's the only one that they will ask us.
Yeah. Yeah, that's strictly. The others is for primary school kids, man. You've grown up now. Yeah.
Thank you.
Okay. So let's quickly get the determinants of those. You'll see how
Number
it falls
two,
in, man.
number
Yes.
two is number 2. It's 50, negative 50.
Yes. Let's corroborate. Let's see what's true. I don't
Negative
trust this
56.
guy. How much is it?
Negative 56.
Positive.
Positive 56. That's the right
Yeah,
answer.
positive.
Positive. Yes,
Yes.
positive 56.
Yes, perfect. That's the right answer. Number 3,
Positive 53 or 54.
positive 54. Let's put the signs so you all can see. Is anyone having problems with that? Oh no, number 3 is definitely wrong. Revise.
minus 67.
There we
Minus
go.
67.
Exactly. Yeah. Should I quickly do it? Can I do number 3?
Is it necessary, sir?
It's not. I can move on. You know, I'm just checking with the house.
Sorry,
Okay.
sorry, Miriam, there by number 2.
Yes.
Is it not 6 minus 56 to become 50? Because 0 multiplied by 0 multiplied by 6.
Exactly.
Okay,
Yeah.
sorry.
Yeah. I know. It's funny when you just mention it. Okay. Is everyone fine with this? Can we move on?
That's the answer for number 3, not 23.
No, definitely not. I can prove it to you. That's 5 times negative 9, right? Which is the first. Remember, we're going this way. We put a negative in, and then we timesing that
minus 45, yeah, negative. Okay, I took a
way. You got it
positive
now.
45. Yes, I got it. I took a positive 45.
Okay. So it's negative 45 and negative 22. I'll tell you something what maths does to the brain. Maths teaches you to become
Sir?
critical. So please, when you're doing this stuff, go step by step. You know, you have to consider each element. Yes, talk to me.
Sir, does it matter where you start with a multiplication? You always have to start from the top, like with the 5 and the 2. In
Yes,
question 3.
there are other approaches, but for now, let me just say yes. It's just keep it like this. You know what I mean? If you get the same answer in a different way, that's also fine. I don't want to bring alternatives yet. You know what I mean? I don't want to confuse everyone. Because if I do that, then everyone's on a different trajectory.
Okay, understood.
Yeah, there are other methods of taking determinants. I can't remember what the other one was called now. I'm gonna just think about it again. So anyway, right? So that's
Sorry, before you proceed there by number 2, is it negative or positive, the answer? I think it's negative. So
no, Chief.
negative 7.
Chief, so 0 times 6, right? You got me? You happy with this? And then it's
Yes, I'm
negative.
happy.
It's negative 7 times 8. So that's negative 56, and that will make that a positive. Hence positive.
Okay,
56.
sorry, my bad. Okay, sorry.
No worries. No need for apologies. All right? What's important is always take note of the mistakes that you make so you can find a way to improve. Guys, we need to move now, no? So what they can also do in the questions is the following. Let me show you. They might give you a solve for X with determinants, right? So it might look something like this. And let me show you what it looks like. Let me go find a random one quickly. And once you understand it, it's fairly simple. Let me just go find one for you. Where is it? Where is it? Can't seem to find one. Okay. It's coming out, don't worry. Okay. I'm just going through the book. I would have liked to check one of the past paper ones. If anyone has a determinant with a past paper, one from solve for X, it'd be nice if you can send it to me. So like this, here we go. So I'm just gonna put in screen him, and then we can solve. So something like this. Okay. Where are we? Okay, here we go. So over here, I hope I'm recording. Okay. On screen. Oh, here we are. I need another solve for X. Okay, can we all see this one? Solve for X.
Yes, sir.
Yes, sir.
Perfect. Yeah, so I'm gonna do that one for you. Then can't we find a liquor past paper one which has that? I think I saw someone in the group do something similar to that.
I got one for you, so if you want.
Yeah, put it in the group for me. Yeah, perfect.
Okay.
Yeah. I'll start with this one and then yeah, okay, cool. Let me just quickly go back. So how we do this one, we apply the same mathematical concept. We're going to say this one times that one, right? Minus that times that. But then we're going to make all of that equal to 7. So they're giving you the determinants value. Okay, so how do we do it? So we're going to say 2x times 5. I hope everyone's happy with that. Minus 3 times negative 4. And all of that's equal to 7. Oops, my bad. There we go. Do we all agree with that?
Yes, sir.
Perfect, right? So we do standard algebra, baby algebra, 10x minus. Remember, Chief, I don't know what is the name. That becomes plus 12, and that's equal 7, huh? You got that?
Yeah, I follow you.
Okay. Don't worry, man. Obviously, we must solve this linear equation. It's 10x. We can say 7 minus 12. I believe the answer here is negative 5. That's 10x. We divide both sides by 10, and therefore our answer is a negative half. You got that? Was it easy?
Yes, sir.
Okay. So, yeah, you give me. I don't want a Kramer's rule one, man. I'm not looking for that one, man. Solve for x1, man. I know what you. Let me find one of the internet quickly. Determinants, solve for x. Yeah. You sometimes I ask you to use determinants to solve for x, or solve equation. I'm gonna get something. I hope I'm gonna get something. Not that one. We're gonna do that. Man, I'm not seeing it here. Let me check engineering math quickly. Okay, for now it's fine. I'll just give you the one in the book. It's okay. Yeah, I want you to solve this thing for me now. Yeah, let me show you. We're gonna come to solving equations now, just now, right? There we go. Yeah, solve that one for me. Okay, there we go. Yeah, perfect. And we have the past paper one. Okay, cool. Yeah. Just tell me Cleo has shared it for us. Just tell us what year that is as well. Is it 2025? Colleagues, can you please solve 2.2? What do you guys get?
X is equal to 3 over 2, or X is equal to negative 4.
Two answers. You got two answers.
Yes,
That
sir.
was
Okay. Cool. Can I try and solve? Can I go? Should I do it?
Yes, sir.
Perfect.
Yes,
So
sir.
Go ahead.
2 times x, right? We all understand we're going this way. You say minus 3 times 4. And we make that equal to minus 5x. Just by the way, you'll never use this ever in your life besides the subject. 2x squared minus 12 equals 5x. Obviously, when you see a x squared, an x, and some constant, you're dealing with something called a quadratic equation. So you want to put that in standard form. So that's going to be 5x, and then you can go minus 12, make that equal to 0. Can we all see that?
Yes,
sir.
yes, yes.
Perfect. Thereafter, we can obviously just do, you can use, there's many ways to solve this guy. You could use your old faithful quadratic equation. I think if I remember right, it's like this, right? Or you can just do the factorization as well, right? Okay, cool. You can also say 2 brackets. We're going to need a 2 and a 1. We're going to need a 6 and a 2 or 3 and a 2, right?
I didn't mind that way, so.
Yeah, no, 3 and a 2 or 3 and a 4. What could it
The
be?
1 and a 6.
A 1 and a 6. No, we need 12. We need 12 over here.
Okay.
So 6 over here.
Minus 3 and plus 4.
Minus 3 and plus 4. Okay, minus 3 and plus 4. I'm not sure. I mean, I didn't. I'll check now for you. I'll check if that is true. This is the way I check. 2x squared, that times that. I know this must give me, this is minus 3. And that is, no, this does not give me 5. That's minus 3 and that's positive 6. So that's not right.
Does. 2 times 4 is 8.
My bad. Yes, that's correct. Yes, 2 times 4 is 8. Yes, thank you. So x will be over here. What is it? 3 over, it's positive 3 over 2, right? And the other one is negative 4.
Yes, sir.
Okay.
Yes, sir.
Yeah. Yes.
Yes.
Someone is talking. You're breaking up, Chief. You're breaking up.
It is x minus 4.
Sorry, I can't hear you.
It is x minus 4. Then the answer is equal to x is equal to 4.
I'm not sure what you're saying. Are you saying that this is minus 4?
X minus 4 in the bracket. Then the
Is this
final
minus 4? Is this
answer
one positive over here? Is this positive? So the way I'll check is 2x times 4 is 8x, right? And then minus 3 times x, or minus 3 and x is negative 3.
It's supposed to be negative.
So 8x minus 3x will give you a positive 5x. Are you with me? That's how I know it's correct.
Yes,
And
it's correct like that.
For sure, I know it's correct. Yes, I'm explaining to that guy. I'm not sure if he knows factorization. Okay, cool. Alternatively, you can use a quadratic equation. All right? Is that fine with everyone? If you don't know factorization, it's time to practice. Can we move on to the one Cleo sent us?
Yes, sir.
Perfect.
Yes, sir.
So this is November.
Okay.
November 2025. Question 2.1. 3 minus 1. Then we have 2x, and that's equal to 4. This was 3 marks. Can you please solve this for 3 marks? For the ones that questions on the previous one, what are your questions? Where are you lost? For the ones who are lost here. Colleagues, I remind you, black label and castle log is not good for the brain. Eh? You got to change what you drink.
2/3, sir.
Okay. Pen is 4/3. X is 4/3, according to that chief. I'm not sure what his name is.
2/3, sir.
2/3.
2/3.
Okay, that's good. Everyone's saying the same thing. Engineering math. Did we all get that?
Yes, sir.
Okay, perfect. It's not tough, eh? Any questions before I move on?
And also, I'm good.
Okay, cool. Great to hear.
What's the question on that one?
It's there in front of you. You're solving for X. When you see an X in determined, you're basically solving for X. Are you with me? I'm not sure if I'm clear. Solve for X.
I get 3.
How do you get 3?
X times 3 is equal to X.
Okay, let me try and solve it. Let me try and solve it. It's 3 times X, right? Minus 1 times 2. And that equals to 4. Are you happy with that?
Yes, sir.
So that's 3X plus what? Plus 2 equal to 4.
Yes.
Oh,
You got it? Got it?
yes.
Okay, perfect.
Okay.
All right. So, point is here, they can ask this, and in determinants we're solving for X, so be conscious of that, right? We discussed what a determinant was, and we were looking at obviously just 2 equations, 2 unknowns. So what I'm going to do now, I'll do something just against the book. The book does it a bit. I want you to remember something, right? The purpose of determinants is to solve a system of linear equations. That's it. It's just another way how to solve it. So I want us to go now to Kramer's rule, right? And we're applying determinants now. That's what we are doing. Okay? And so let me quickly show you what this looks like. And I'll show you how to apply. Let me just okay. Let me do this. Okay. Okay. So reverting back to this over here, right? That's a very important concept, and I want to show you how we're gonna use it to solve equations. I'm just gonna do this, and I want to write here the purpose of using determinants or what we call Kramer's rule is to solve a system of equations, right? It could be 2 equations, 2 unknowns, 3 equations, 3 unknowns, 4 equations, 4 unknowns. So what is Kramer's rule? Let me show you. The Kramer's rule is basically this over here, but there's a way there's a way it's written, and I'll show you what I mean. So to find X, you need determinant of X. What do you guys call the determinant? Is it delta, no? I'll just say delta X over delta Z, delta So well, what I mean, it looks like this. So it's delta x. That's determinant of x divided by that, and y equals determinant of that. What these guys are, right, are these parts here, right? This section here. But I'm going to show you how you can remember how to solve, how to remember each determinant. So you need a delta x, a delta 0, and a delta y. How do we find them? Let me show you. So to find, these are the steps outlined in the book, right? You want to start with delta 0. So to find the terms for delta 0, right? All you must do is, obviously you have your equations, you put it into the standard form, that must be said. When you want to find constants, the delta 0 is a constant determinant, you eliminate those terms. And therefore your coefficient for the delta 0 will be A1, B1, A2, B2, right? That's a determinant. We're also going to need a delta x, a determinant x. And to find the x determinant, right, we eliminate the x terms. So I think I should say it here. Eliminate constant terms. And then here, eliminate x terms. So when we eliminate the x terms, we need to find those respective coefficients. So we eliminate those terms. Our coefficients of B1, C1, and B2, C2. Is everyone with me? Are we on the same page?
Yes, sir.
Yes, sir.
If not, you must just say,
Yes,
I don't
sir.
understand what I'm saying. So I'm just explaining what's going on. So if I want to find the y terms, I eliminate y from this over here. So I come back here and I eliminate y. Where's this? Okay, so I eliminate this. My coefficients are A1, C1. And then it's A2, C2. And so what I'm saying is that for us to find the x value, right, you must find determinant x, which is B1, C1, B2, C2. And then we must divide that by determinant 0, which is A1, B1, A2, B2, which is essentially this over here. Are you with me? So instead of calling it whatever that is, we just call it a determinant x or determinant y, just like that. See there? Now, let me illustrate, and you're going to use determinants to solve. I'll use the one we just did. Okay, cool. So first things first, we put in standard form, no? And sorry, here's the here's the thing. Now, okay, it's just a bit strange, man. Anyway, let me not. Yeah, so let's do it like this. Now, I might come towards certain books not keeping this equal to 0, but I'm going with the info book and I'm trusting that that's that. So you have two equations looking funny. You know, different variables, they're arranged differently. You want to put it in standard form. AX, BY equals some constant. We assume that this is a standard form. So let me apply what I just told you now before in terms of finding determinant 0, which is the constants, and then x, and then so on. So determinant 0, we have to eliminate the constant, right? Are you with me? So therefore, our determinant 0 is going to be 3, 4, 2, and -5. Is that cool? Is everyone following what I just did there? I just took the coefficients.
Yes,
Perfect. So that's x. Sorry. So let's find determinant x, right? So if you want the x1, what do? We eliminate the x terms, right? So give me the coefficients for the x term.
4,
Yes, perfect.
13,
Yes,
and 5 and 1.
-5.
-5, yeah, sorry.
Yes, perfect. I like that. Can someone else give me? And if you want the y terms, we eliminate the y, right? We're applying a similar principle even when you do 3 equations, 3 unknowns. So what are my coefficients over here?
That should
Sorry?
be 3,
Yes.
and 18, and then it's 2 and 1.
Perfect. Okay. So what I want here now, you must find the determinant for me here of all three of them. Because remember, all we're going to do is once you have determinant, you're going to say x is going to be determinant x over determinant 0.
Sorry, sir.
Yes.
Just a question. Don't you substitute the constant in the place of say x or y? Because then the matrix will change if we just eliminate it like it is.
How do you mean?
Yes.
Like you've got for delta x, you've got 4, 13 minus 5, 1.
Yeah.
Isn't that supposed to be 13? And then the y, and then the 1, the constant in the place of the x's.
I'm not sure what you mean by that.
So okay, you've got delta.
So I think she
x.
means. Sorry, sir. I think she means she wants where y is on the standard form. She wants it on the right hand side of.
Okay, let me just quickly see it. Let me just move through this quickly. Okay. Let me just confirm my delta. The first thing one would then come to, I normally keep this equal to 0. Let me just quickly see. So we have 3, 4, 2, and -5, right? We're happy with this one, huh?
Yeah.
Okay. And then let me look at the second one. So delta x, if I want my x, I remove my x, right?
But
So
don't we substitute the constants, the c, into x's place, like on the left hand side?
You know what? You know what the problem is? I'm realizing something now. It's this approach. Okay, you know what? Let me show you. I just want to check something. I see what you're talking about. Now this is the issue. Yeah. So when I normally do this, it looks like this. It's 3x. This is a standard way. Let me show you 4y minus 13 equals 0. Right? This is what's supposed to be done. That's -1. Are we happy with that now? So let me just quickly look at what they are doing here, which is 13 and 4. Okay. I see the nonsense they're doing. Okay. So the first thing is put it into this form. Is everyone happy with this?
So, but isn't that also going to give us a different answer?
No, don't worry. Calm down. Put it in this form, right? I put my terms in. So it's going to be 4, what is it? 4 and -13, right? And -5 and -1. Okay? And then on the y side, it's going to be 3, -13, 2, and -1. In the book, what I can tell you is because your constant is on the other side, that is why they do that. So just watch, right? So find the determinant of the first one. Do it for me quickly. I'll show you now. Their way is actually a suspicious way, but anyway, just do it like this. What's my first determinant?
-23.
How much?
-23.
-23. Is everyone happy with that one? I'm not sure. -23. Do delta x for me.
-69.
Positive or negative?
Positive.
It can't be because that's a negative and there's a negative. Just check.
That's going to be -69, sir.
Yeah, -69, exactly. Right? And what is my delta y? I'm going to go to the book now. I'm going to check.
Going to be 23, sir.
Are you sure positive or -23?
Positive, sir.
Okay. I see the answer -23 here. I'm just checking the book. I'm not sure they're right.
Why substitute? Let me just see you.
Yeah. So their ways a bit, yeah, I'll come to their way now. Just check, it's -3 minus. So yeah, it'll be -3 plus 26. So -23. Oh, it's -23. Yeah, it is. -3 minus. Sorry, plus 26. Yeah. Got it. Can the colleague who was asking about this just come up again and just check the answers? There's a woman.
Yeah,
Yes, here
that's
you
me.
are, right?
Yeah.
Yeah. So what did you get for delta x? Negative 69, right?
Yes.
And then negative what? And this one?
I was still busy now before we.
Okay.
It's -3 minus 26. So what is that?
Negative 23.
Yeah, that's right.
Okay. So I hope everyone got this. If they didn't get it, we'll come back to it now. But can you see the problem with the book here, right? They are flipping 13 and 4. They are flipping 1 in 5. Can you see? This, I think, is very confusing. The best thing you just do, you make it equal to 0, right? And you eliminate the terms like that. I don't know if this is going to be better, but I promise you that it really is. Because that's how I do it.
Yeah.
Because you can't have.
Yeah, it looks better on that way.
Which way? My way or this way?
No, the way that you just did it now.
Yeah, because this one is confusing. Now you're flipping these numbers. It's just simple eliminating stuff. It's really no need to do that. I promise you. Colleagues, is there any questions with this before we solve for X and Y?
Sir?
Yes.
Delta Y is going to be positive 23, sir.
It cannot be. It's -1 times 3, right?
Yes, sir. It's gonna be
Minus 2 minus 13. Therefore, that's -3, and that's plus 26.
Yes, it's going to be plus 23.
Plus 23.
I also get
Yes, sir.
23,
Minus
yes.
Oh,
3.
my bad. My sorry, guys.
Yes.
I also get plus 23 here. But isn't that supposed to be a negative 2?
I'm checking here. Something is
Supposed
suspicious.
to be negative 2, sir. The 2
Negative. Oh,
times.
-2. No, man. Where?
Positive.
So I get
No, it can be negative 2. 2 times 13. That's way more than negative 2.
I get minus 29.
I'm just checking something. Just give me a second. Just give me a second.
Because I also got negative 23.
Yeah, just give me a second. 3 times that, -1, 2. Let me just confirm something.
The 1 is supposed to be a positive.
The 1's supposed to be a positive.
And the 2 is supposed to be a negative.
No, man. Wait. No, not according to this here. You can see it's quite clearly here. 3 plus 4, -13. That's fine. 2, -5, -1. That's perfect. Okay. No. It's cool. It's fine. I think it's positive. It's positive. I'm just checking our answers here. You guys got 1 and 3, right? I'm gonna check. I want to check if this works out. I just want to check if it works out. Just give me a moment. Just give me a moment. 3 times 3 plus 4 times 1 gives me 30. Okay. Okay, cool. So let me just figure out what's going on. Why am I not getting my -3? Why am I not getting negative? What am I not doing here? -3 times that, that's correct, right? My coefficients are at the y, I eliminate this, it's 3, -13. Okay, 2, -1. 3 times -1 is it's -3. Minus 2 times something is dubious.
Negative. Can I raise my hand here, sir?
Just hold on, Kuti. Yeah. I think I know what's going on here. So this one is not -23. This is 3 times -5, right? You see here? Minus 2 times 4. This will give you -15. And this will give you, geez, it is -23. Okay, yes, I'm listening.
So can I? Earlier we did it's the same equations as earlier on. So the answers that we got was 1. And I can't remember the other one because I'm at work currently. But then
I know. It should be 3 and 1. That's correct, yeah.
I use Kramer's law, you see, sir, and that is how I got -23 for delta and -23 for delta y.
Now,
so then
I'm doing the same thing. Don't get me wrong, but I'm trying to figure out why am I not getting my
So
negative
I'm
23?
trying to explain to you now. So you see the one that you made a negative one,
Yes.
right? That one is supposed to be a positive one, and the two that is a positive two by you is supposed to be a negative two, because that is how I got my answer. But
No,
it's supposed
check
to be
this. Hold on. I hear
okay.
you. I carry this over to the other side. No? That's 2x, right? Everything on that side of it is 2x minus 5 minus 1 equals 0. That looks right to me.
I'm gonna send a picture in the group of my one quickly. So
Yeah.
how I got it.
Yeah.
'Cause
That's
I said
I think
negative
what
is
I'm trying to
supposed
say, it's not about like how you got it or what. Like there's a standard approach. It just doesn't change. So I'm trying to figure out why am I not getting that. But let me just check. So I know that
the second equation you should make it standard. I think maybe that is the confusion. With
did I not make it standard over here?
2x. You see the minus one is supposed to become a positive one. What? No, I'm mistaken. I'm sorry for that.
You
Sorry
see
for
what
that.
I'm saying?
Yeah,
Yeah,
sir.
I'm checking all of that here. This is what's I don't know why what's not adding up here. Okay, you know what? Let me see. So right, anyway, let's solve for now our x. Our x is going to be delta x divided by delta 0. Cool. And y is going to be delta y divided by delta 0. Again, this delta 0 is coming from that term over here, right? It's the same thing at the bottom. I'm going to check what's going on. I'm not sure. Can you please mute your mic? So let's quickly just do this. So our delta x was negative 69 divided by negative 23. Okay? Delta y is plus 23 or negative is a plus 23. No, what's the issue here? Yeah. Okay, it's plus 23 divided by negative 23, right? We all can agree this gives us 3, am I right? Are we all happy with this?
Yes, sir.
Okay, and then of course, this will give us negative 1, which is a bit suspicious now, which is not going to balance out the equation. So let me just quickly see. 3 plus. That's something I'm missing, man. Something so obvious. I don't know why. Let me see here. Something so obvious, which is not prevailing. Okay, let me have a look. Let me have
So
a look.
y is positive 1.
Y is positive 1.
Yes, it's
Yes,
negative.
is positive
Delta y is negative 23 divided by negative 23.
So, guys, I think what's bothering me here, I'm not seeing here, right? So it's 3 times negative 1 is negative. Oh, you say this is positive 1.
The y will be positive 1. Yes.
You know what's messing us up here? The y is positive 1. The reason what's messing us up here, I think something they did
The
is
class.
Often right siyajola kaloku inyanzelekile misengam yabona
Chief, we can hear you, eh? Zakanya.
New time.
asikenzi into banalo
Zakanya, we can hear you.
ndiyayibona mani into kan ezayo uba iyathini.
Eh, singalaka. Mutani.
Ulibele sana.
Hey.
Yo.
Okay, let's quickly check. So it's negative 2 minus 5, right? That comes over, and that's 1. It's negative 1. I don't see anything wrong, man. There's something what happened here. It's either this should have been a plus or something. There's something is not balancing here.
I think we're overcomplicating.
So
Yeah.
the thing is, how I got minus 23 by delta y.
Yes.
Standard form that they gave us here, the solution. They substitute plus 13 plus 1. So it's 3 13 to 1. And then when you do the equation, you get minus 23. So, but then for delta x, it's going to be positive 69. So if you substitute it to get x, it's going to be minus 3, and then it's going to be plus 1 for y.
So you're saying y is plus 1 and x is negative 3.
Yes, if you use the standard form that they gave us there.
Oh man, that's not supposed to do this, man.
So what they're doing in the textbook, they're leaving the coefficients on the other side of the equal sign.
Yes.
Yeah, I know
Yes.
that. Yeah, I'm aware of that. I'm aware of that. Yeah, I'm well aware. But like I said, I mean, it's not supposed to do this. Okay, okay, okay. Cool. That's fine. That's fine. So their method, I promise you. So what I'll do now, I'll give another one, right? And then I want you guys to try that. Just and then just use determinants to solve. I'll give you one now. I'm gonna check, man. Something is like way off. So solve this will be by determinants, no? Okay. Just give me a second. I want to prepare it now for you. Something is way off, man. Okay. So try this one for me. Let me just, where's the other one, man? Yeah, use this one. Just super strange, but anyway, I need to have a look, man. I've done this like how many times, and still I'm like, no. Okay, do this one for me, right? Let me have a look. Colleague, can you just please try this one over here? Let me just have a look. Absolutely something very strange. I need to check. And what I'm doing is Kramer's rule. So yeah, rest assured is Kramer's rule. Okay, yeah. Can do this one for me while I'm checking that other one. And I want to see what's going on here. Just want to confirm. Okay, that's fine. And once you're done with delta zero, you can just let me know what you got, eh? So I can write it down. I'm checking. There is no way, like I am that confident that this doesn't make sense. I need to look at this book. And I'm checking exactly what's going on over here. So you can do it your way. I just want to see something. But strange, man. Okay, let me work it. Let me work it. You know what? Guys, I forgot something. Sorry, my bad. I forgot something. Yeah, I forgot something. It's my bad. I remember now. Okay, cool. So when you're what I should have shown you, right? And I apologize for not showing you. It's my bad. So when you're using this particular way, right? What is of critical importance, and this is why I should have solved for y, is that the equation for Kramer's rule, right? And I can see why they simplified, which is not exactly correct. It looks like this, man. Right? So you have x over discriminant 1 equals y over discriminant 2 over 1 over delta 0. And the reason why this is negative is actually when you solve for these equations, you actually notice that this will come out negative, man. I just took as the book says, and this is the problem with just straightforward formulas. So once you have this over here, it's exactly the same. So you have x, delta 1 was given, or delta x, sorry, delta 1, delta x, same thing. Let me just change it for you. I feel like I'm messing your brains up now. That'll be negative 23. Delta 0 is negative 20. Delta x is negative 69. Negative y, so that'll be positive. That'll be positive 23, but that's why it's negative 23 over here. That's fine. Delta y is given as 23. Oh, sorry, my bad. So this is y, negative 23, and then delta, what is this? Delta 0 is 1 over negative 23. So the formula, which I should have shown you and not just rush into this one, is basically this over here. And that's coming from when you actually sort this y out and they change some of these parameters. But nevertheless, I've got it now. I'm sorted now. Okay, cool. I see what I was missing. All right, can I get my delta 0 for this one? Or delta 0, delta x, delta 1. Okay, cool. I got it now, man. Sorry about that.
So for delta 0, I got negative 24.
Okay, negative 24. That's cool.
29.
No.
Negative 29.
Negative 29.
Okay, let's see. I'll give it to him. I'll check now. I'll check now.
Minus 116.
Yeah.
Yeah, minus.
What, this one?
Minus 116.
Yeah,
One?
that's delta x minus 116.
Okay. Yeah.
And then it's minus 88.
Minus 88. Okay. Cool. So let me check. Let me check two of them. So like I'll do my approach now. So again, what I should have mentioned was to find the. I mean, if you do your one, it's also perfectly fine. There's no qualm. It does the same thing. So delta. I'm going to check now. I'm checking. So delta 0. So what is key to solve the stuff is x over delta x equals negative y, right? Delta y. There's a reason why that is there. If you, when you do 3 by 3, you'll see. And this is going to be 1 over delta 0. So that's where I should actually start. So let me do delta x quickly. Delta x, I remove my x's. Right? It doesn't matter where you start, delta x or delta y. But anyway, so that's going to be 5, negative 7, negative 3, negative 19. Perfect. That should be 5 times negative 19 minus negative 3 times negative 7. Okay. Let me check that answer. And in terms of that should be negative 116. That's correct, right? We got that. My delta y is going to be, I eliminate my y terms over here. I eliminate my y. I have 3, negative 7, 4, and negative 19. Okay. That should give me 3 times negative 19 minus 4 times negative 7. Okay. And I got negative 29. You guys all get, everyone got negative 29 as well, right?
Yes, sir.
Yeah, delta 0.
Yes, sir.
Yeah, delta 0 is going to be, I come here, I eliminate, I'll eliminate constants. So eliminate that. I have 3, 5, 3, 5, and 4, negative 3. Okay, and then this will be now 3 times negative 3 minus 20 base here, right? And I get negative 29. Okay. No. This is delta 0 now, or negative 29?
Doing the same one, so.
Let me check. No, it's 3 times 3, right? Yeah, 3 times negative 3 minus that over there. Let me just check here. 3 times negative 19 minus minus negative 4 times 7.
So it gives us negative 29.
They're both negative 29, isn't it?
Yes.
Yeah, there we go. Exactly. Okay. So this is not correct here.
And
Check it
delta
out.
y give us 29.
Okay, good. Yeah, you'll talk about that. It's 29. It's fine. I'll just say it's 29, right? So then if I use my approach over here, which is the standard approach, is going to be, we're just going to substitute these values into the setup over here. So x, we don't know yet. So we can combine this equation and that equation. So it's 1 over here. So my delta x is negative 116. And then delta 0 is negative 29. Solving this equation, x will be basically, it's like I said to you, it'll be delta x divided by delta 0. So it's negative 116 divided by negative 29. This is the same as what I had earlier on when I'm saying delta x over, as you can see, it's that divided by that over there. The answer to that should be how much? 116 divided by, so it's 4, right?
Yes,
You'll
sir.
get 4. Perfect. With this one, I have a negative attached to that equation, so this would be negative y delta y equals 1 over delta 0. And then I just obviously rearrange it. This will become negative delta y over delta 0. Can you see that? That's why my sign changes. Can you see that? So you have a 29, I have a, it's the same thing. Are you guys with me? So it's a negative. This is going to be plus what? Plus 29, am I right? Well, let me just write it the right way. Negative
Perfect.
29 divided by negative 29. So therefore, y is going to be negative 1. Am I right? Is that correct, colleagues?
Yes.
Yes, sir.
Yes, sir.
Can someone mute your mic there? Is there any questions before I move on?
Yes, can you can you just explain that process again, please? Man, I lost you somewhere.
Okay. So I think, let me just show you, man, what I missed out on. Like in terms of the math. Well, I wouldn't say missed out on. I didn't do, man. So I'll show it to you over here. And okay, yeah. So let me just quickly share. I'll show you the process again. Let me just unshare and then I'll show you. Where is I can try another one. We can do another one. Okay, so I'm gonna just share my Chrome over here. Okay, cool. Yeah, so this was what we were doing earlier on, right? We have the two equations. We solve for the x. Can we all see that equation? It's the same one. Can we see it over there? Remember
Yes,
the
sir.
A1, B1? Yeah.
Yes.
And then when you actually solve for the y variable, you would have noticed there's actually a negative sign there. You see what I'm saying to you, which is not actually shown in the previous one. That book didn't show you that. So that negative sign is of critical importance in that case. So anyway, reverting back down to what I was talking about, the process to solve an equation like this, the steps are as follows, right? You want to first find delta 0, you omit the constant terms. You omit the constant terms, you're going to have 5, 2, 3, and 4, right? That's your first determinant. You find the determinant, you get the answer. When you find delta 1 or delta x, omit the x terms. You eliminate that, then you're going to have 2, 19, 4, and 17. Okay? Find the determinant, get an answer. You want to find delta y, which is in this case delta 2. You eliminate the y terms. The terms should be 5, 19, 3, and 17. Right? So they're 5, 19, 3, and 17. once you're done with this, you basically plug all of that back into this equation, like I said to you. However, that being said, this is Kramer's rule, by the way. That being said, and I see the textbook is doing something completely different. And they're making sure that the values stay positive, right? So in this case, what they're doing, they're saying 3, 4, 2, -5, right? That's the easy part. Then they come over here to delta x. They say 13, 4, 1, -5. Can you see what I'm saying to you, right? They're working that way. Then you do delta
Perfect.
y, you say 13, 1, and 3 and 2. So, yeah, that's the same thing. But this one is not mathematically first principles sound, but anyway. Yes, any questions? Talk to me, guys. Talk.
Currently at work, sir.
So can we
Ask a question quickly about the test.
I'm hearing two people talk. Can we get the one person first?
So I'm currently at work, so I will have to
so
go.
so can we stick
Just
to the
hold
way
on.
the textbook does it?
You can speak, so it's okay.
Okay, cool. Yes.
Sorry, sir. Can we stick to the way the textbook does it for the exams?
That's fine. It does the same job. You know what I mean? No problem.
So
Yeah.
my question is
Yes.
regarding the test, because I'm currently at work and I won't be able to attend the class further. But can I ask a question regarding the test, sir?
Well, not now.
But I won't be able to come back to the meeting now. That's the thing, sir.
You can just send me a WhatsApp and I can answer it.
Thank you.
Okay, cool. So let's try this one. What came in the group, right? Okay. I'm assuming, can we all solve 2 by 2, 2 equations, 2 unknowns here?
Sorry,
Can
sir.
we all do that?
Sorry,
Yes or
sir.
no?
Yes, sir.
Okay. Tell me no.
Yes.
If no, please tell me.
Sir,
Yes.
can we just go back to the one that we were doing?
The previous one. This one here.
The one that we were doing and now, yeah.
This
Where
one
we
here.
delta x and delta y, where we sort got the figures for that.
Yeah. Okay.
Just explain to me the step after that, please, man.
After where? You mean to solve them?
No, I know how to solve them, delta x and y and 0. But the step after that.
Okay, so if I'm going to do the books approach, right? That's what the colleagues would like, which is a very dangerous approach of doing this stuff, in my opinion. You basically say your x is equal to your delta x divided by that, right? And then your y will be equal to your delta y divided by, are you with me? That's the next step. So once you add the determinants, you just substitute them into these equations over here. Are you with me?
Yes, sir.
So like what's bothering you? So what I'm saying is once you have a delta x, you're going to say negative 116 divided by delta 0, which is negative 29.
Just say your screen, there, sir. Just say your
Excuse
screen.
me?
Just say your screen where we did this.
What am I sharing now? A book now? No?
You're showing the book, yeah.
Oh, my bad. I realize now. Okay, cool. I'll show you now. Yeah. Can you see? Yeah. That's the next step. Are you with me? Delta x divided by delta. Yeah. And then just delta y divided by delta 0. This is all coming from that over here. That over here on top is delta x and the bottom part is delta 0. Can you see?
Yes, sir.
That's yeah. I hope you get it.
Can you just go back? I would just like to write.
Yeah. You can always come back and record, I mean, we'll get the recording.
Sure.
Yeah.
Is that bottom half there by the line? The bottom half of it, is that how it's done in the book?
Excuse me?
Is that bottom half how it's done in the book? Bottom of that line.
No, I explained to you. You see, guys, this book thing is it'll destroy you later on. But anyway, let me show you. It can work. This is how the book does it. Must I do the book way for you?
I want to do your way so first. First your way.
No.
You can trust the book also, man. It's all right, but I know already. So what the book does now, let me just quickly do this one. I'll go over it. I'll do this one the book way, which is 3x. Let me just do it this way. Just do it here. I'll just quickly do it. Oh, okay. Give me a second. Yeah. So the book, their standard form is like this. It's also essentially correct, man. Maths has many ways to do something, but I know why I don't like it. But anyway, so that's what the book does. We take the determinants the same way, right? So if you want the x, if you want delta, if you want the constants, right? You eliminate the constants, you take the coefficients of those. 3, 5, and then 4 and -3. Are you happy with that one? Delta x. Can you do delta 0?
Yes, sir.
Okay, cool. And so now, and then when you do the books way, when you want to solve for what are we looking for? For x, right? You eliminate the x, right? You eliminate the x. And if you eliminate x, which is that line, it's going to be 5. Is it 5? Or what is it? 5, 7. And then
-3 and 9.
it's not swapped around. It's 5, 7.
And -3 and 19.
Yeah, so it's 5, 7.
No, it's 7, 5, 19.
Yeah, 7, 5. That's what I'm saying. So the book works. This is what I'm saying. This other one works this way, right? So you're going to say, what is it? 7, 5, and what?
19 and -3.
And -3. Can you see what it does? 7, 19, 5, and -3. You start that way, which is, again, yeah, anyway. Delta y.
Confusing, yeah.
It's not mathematically making sense. That's the issue with my thing. So you find the other one. If you want to find delta y, you eliminate. What are we doing? Yeah, so we eliminate x, right? No. What am I doing here? What am I doing? X. 7. Yeah. So we eliminate y. Huh? Yeah, there we go. So it's going to be 7, 3. 7, 3, and
It's going to be 3, 7, and 4, 19.
3, 6. My word, man. Yeah. That's why I like. That's super dangerous, man. It's a lot of remembering, man. It's not supposed to be like that. It's just a procedure you must follow. So either way is fine, man. Or we should come up to the same answers at the end. So yeah. So I don't know. Whatever you prefer. Okay. But if you're using my way, what is key to remember that the y has a negative attached to it over here. Yeah. That's what's key. And you'll see you'll be saved right through the whole thing. Okay. Can we move on? To the next part. How long is the session? Okay, cool. So now we're moving away from 2 by 2, and we're going to start doing 3 by 3 now. Okay, that's where we are now. So let me try my best to get through this. So 3 by 3 is a bit more. It's got a bit more interesting twists, but it's kind of the same thing, right? Some really unnecessary information, but anyway. So let's look at what is a 3 by 3. Okay, so 3 by 3, what I mean by that, a third order determinant. It has 3 unknowns, 3 unknowns, 3 equations. Again, the purpose of doing all of this, I'll show you right now, is to solve equations. We have 3 equations, and 3 unknowns, like this. Case in point over there, right? Again, something like that. You have an X, Y, and Z, X, Y, Z, X, Y, Z. So then you obviously need to know how to sort that out. So let's quickly go through it from the start, and I hope you can end off with the 3x3 equations. So there's a few factors we must go over. And the one is, okay, so the question is, how do we find the determinant of a 3x3? Now, it could have been super simple. This book really makes it unnecessarily a lot of explanation over here, but let me try and explain it. So let's discuss the term, what is a minor, right? A minor of a particular element. Okay, so before I say a minor, let's first categorize the elements. Can you please mute your mic? So the first element will be called 1, 1. That's the first row, first column, right? So this is a row going to the left or right, and then up or down will be a column, right? Don't know how do you remember that? So first element is A11, second is A12, A13. That means first row, okay, I think we all get the idea, you know, second, third, and so on. Okay, cool. Then to find the minor, how do we find the something called a minor? So this is just terminology. You'll get used to it. It could have been very simple to explain this, but the idea is that what they say, it results from deleting the row and column in which the element lies. So let me explain to you how do we find the minor. Let me illustrate using this over here. So I'm just gonna screenshot this and we'll do an example. I could have shown you how to find the determinant straight away without all this preamble. But yeah, there we go. Let me just make it like that. And stop that. Share. And then, okay, cool. So how do I find my minor, right? Really, this could have been done a lot better, but okay, here we go. I think someone's mic is... Yeah. So if you're working with this element here, right? The first one, A11. Can you guys hear me? Hello?
Yes, sir.
Okay, perfect. So to work with the first one, right? To find
Yes,
its
sir.
minor, all we have to do is eliminate the row and column in which it's in. And then you basically end off with a determinant. So what I'm saying to you is its minor, as we call it, A11's minor is basically equal to A22, A23, A32, and A33. By the way, these are all steps in order to solve a 3x3 equation. So that's that one. So if I have to do A22, let me quickly do that for you. A22 is over here, right? Therefore, we must eliminate each respective column and each respective row. So can you see the missing, the remaining elements? Each minor then will be, what is it? A21, A25, A31, and A33. Could we all manage that one? Can we all see what I'm doing? That's it. Again, you understand why you're doing this later on, soon, very soon. Are we all happy with that? Can I ask you now? Find for me A23 and find for me I want A23, I want A31.
Sorry, it's A23, the one that you just did. It's not A25, it's A23. It's A21 and A23, not A21 and A25.
I think my handwriting is bad, brother, man. That's a problem. It's supposed to be a 3, man. You see here? It's a 3. A21, A23. A31, A33.
Ah.
Yeah,
Yes,
it's my
yes, yes.
handwriting. Yeah. Do for me A23 and A31. Give me its so-called mine.
So for 823.
Yes. A23 now.
Yeah, 823, yes.
Yeah.
I got A11.
Let me just check. Are you sure about that? A23
Yes.
is over here. So eliminating that row and that one.
No, so you're gonna why are you gonna take away the top one as well?
You
Yeah,
have to
because
eliminate.
even me, I was under the impression is that it's gonna be this far right column and the middle column,
Yeah.
not the top one.
Yes.
So A23, right? So let me come back to A11, right? So wherever the element is, you're eliminating the row where it's in and the column. Are we happy with that?
Yes, sir.
Okay. So if I do A23, right? I'm over here. Am I correct?
Yes, sir.
And I eliminate that one and that one. I'm left with those ones.
No, so you're
No,
gonna take away the middle row.
Oh,
Yeah, I
my
concur with
bad. Sorry, you're right.
Yes, sir.
yes, middle row.
Yes. Sorry. My bad. Thank you. A11, A12, A31, and A32. Forgive me. Yeah.
Yeah, it's good to say yes.
Cool. And then the next one?
Got A12.
Let's see, A12.
A12.
A13.
Yes.
A13.
That's gonna be A22.
A122.
A22.
That's gonna be A23.
A23.
Okay. Could we all do that?
Okay.
Yes, sir.
Okay, cool. So that's the minor part, right? I'm assuming you all can do that. So let me just give you one way with some numbers in. So what I might do in the test is one of these ones. I'm just gonna print screen for you. Then yeah, I guess it's how they break up the work here. So what they want here, they'll give you the 3x3 matrix, and they're asking calculate the minors of these elements. So this is what they mean by minor. We're not at cofactors yet. So I want of element 3, element 2, and 1. So you guys will tell me the answers to these ones. Same procedure, just with numbers now. Eliminate the row and column wherever that element is, and take the remaining, and you find the determinant of those ones. So obviously in the previous one, sorry about that, we didn't find the determinants of this yet, but the point is to find the determinants afterwards. Yeah, which I wanted to get to, but okay. Let me do the first one, and then you can do the other two. Yeah. So again, defining the minor. How do you do the minor? It's going to be 3. And then that. Are we happy with that, right?
Yes.
Yes.
Yeah, so then we have 7, 2, 1, and 8. We do the standard determinant, which is 7 times 8 minus 2 times 1. And that gives us 56 minus 54, right?
Yes.
Yeah, perfect. So you can try the next one for me. So we're still applying determinants over here.
Zero, so.
Yep, that's correct. Did we all get 0 for the second one?
Yes.
And for the third one?
Minus 18, sir.
Minus how much?
18.
Okay. Did we all get the Did we all get the same answers?
Yes, sir.
Okay, is there anyone
Yes,
else
sir.
who's unsure? There's a lot of students here. Rema, Sabelo, Dylan, Bianca,
Yes, yes,
Fred.
yes, yes. No, we're following, we're following, we're
Okay.
following.
Great, great. Is it Lisa Kanya? Who's that? I'm checking the names now. Okay, cool. Oh, it is you. Yeah. Perfect. So now, once we've done this, we can look at something called the cofactor, right? Now, let me just share the book. Excuse me. Now the cofactor mine is nearly the same, but the only difference with the cofactor is a minor with a particular sign. Now, what I recommend, right, instead of using this equation over here, which is very unnecessary, right? It's not even explained to you how it's developed. All you have to do is basically know whether determine in the matrix it follows a certain pattern in terms of position. So if I make this big for 3 by 3, and I'll show you what I mean. All you must remember: positive, negative, positive, negative, positive, negative, positive, negative, positive. For 3 by 3. That's it. This should have been explained of how they actually got this. But for now, if you just remember that over there for 3 by 3, you're perfectly fine. And I'll show you what I mean by this. So you can do this if you want, no problem. It explains if it's in a certain row or a certain column. If you want me to explain, I will, no problems. But like I said to you, there's really no need. So let me quickly do this one. And now I said, now we're not finding minus, we're finding something called cofactor. The only difference between the two, there is now a sign attached to the so-called minor. And I'll show you what it looks like. So let me just quickly share. So instead of doing the computation, right, which you can do if you want, it's a waste of time. All I look at is this, right? And we're all dealing with, and it's all processed in the 3 by 3. It's the following. Like I said, plus, minus, plus, minus, minus, plus. If you write this down, you're more than fine. When you do that equation thing, it's going to come out to the same sign. So what I'm saying is, in the first, the sign of the first element will be a plus. The second will be a negative. The third will be a 9. The second one will be a negative. And that'll be. So let me show you. So once on the cofactor, when cofactor number 2, we come over here. Wherever this is, we eliminate, right? Like I said to you, that's going to be 4, 0, 2, and negative 2. And the only difference is because it's here at that position.
Sir.
Yes.
It's not 4 and 0, 7 and negative 2.
My bad. I'm getting tired. It's been too long. It's
3 and 9.
3, 9. There we go. 3, 9, 7, and negative 2.
Negative 2.
So if you're on that side, right, at 2, it just means your sign will be negative here. So when you find your determinant, right, it's going to be 3 times negative 2. The negative will be here. 3 times negative 2. You just sort out the determinant first. Minus 7 times 9, am I right? And that should give us what? It gives us, it's basically like a negative 1 there. Gives us negative 6, right? Minus 63, right?
Yes,
Is it correct? Which gives you negative 69, am I right? Are you guys with me?
Yes, sir.
Yeah, and then all you do is you times by the negative 1, which is outside over there. And that's it. And then your answer will be 69. That's the difference between the minor and the cofactor. That's all. So like I said, instead of memorizing this thing, which I'll show you how it works, but it's really not I don't know, man. Let me quickly show you what the formula looks like.
I don't think you must bother with that.
Yeah.
It's very complicated. It's not complicated, but it's a waste of time if we remember this.
That's what I'm saying. There's no need to, you know what I mean?
Gonna
Go
make
over it.
us all
Yeah.
confused now.
Yeah.
So we don't need to go study that formula. We can do it this way. You
That's
just
what I'm saying. That's what I'm saying. It does the same job. And I mean, you can try it out. You know what I'm saying to you? Just know the positions are alternating. Plus, minus, plus, minus, plus, negative, plus. You know what I mean? So let's quickly try this one over here. No? Number 7. Then I want you to do the next one. So I'll do number 2, just to recap. Yeah, number 2 is over here. 1, 3, 9, 2, 4, 0, 8, 7, negative 2. And 7 is over here. We eliminate this guy. We eliminate this guy. So therefore, we have 1, 9, 2, and 0. And like I said to you, because in this position, 7, the sign will be negative. That's it. You put it over here. You find the determinant of this guy. So that's negative. Keep the bracket like that. It's 1 times 0, right? Let's make another bracket like that. Square bracket. Minus 2 times 9. Okay. And then that's negative 18, am I right? And then negative 18 times 1 is? It's a negative 18.
18.
Yes, 18.
My sign's all right, guys. Let me just check my signs because my eyes is burning. 1, 9, 2, and 0, right? 1 times 0. The answer should be positive 18, right? Yeah, there we go. That's negative 1, negative 18, and then the answer is 18.
18.
Yeah, and you can check on the book is exactly the same. So I recommend you know this instead of wasting your time with that formula. Because maths is not supposed to be a case of memorization. I can explain to you where this plus minus comes from the alternating signs, but anyway. So let me just do for me number 9 as well, finding the cofactor. If you guys can do that for me. Oh, how long is the session? Okay, we must conclude all this. Yeah.
Sorry, sir, just explain that negative 1 there.
So what I'm saying is, it's not, I'm just putting a negative 1 for illustration. You could have removed the negative 1. You know what I'm saying to you? Where the negative is coming from is based on the position of the respective element. You see there? So I'm just saying, if you remember this, you should be all right. And it's easy to remember. So I'm just putting a negative 1 deliberately so you can see I'm times my negative 1. But I don't need to do that. I could have put it here as well. You see? You got me?
Okay, I understand. Yeah.
Yeah, but you can see, there is a 1, invisible 1 as they call it. Okay, do number 9 for me. Then I want us to conclude with something interesting. Kramer's rule N4. Just want to see how they actually, there's a note I can pull here. Just tell me done that element, I'll just check. What's your cofactor for 9?
I got negative 18, sir.
Okay. I'm not sure that's correct. Can we check? Check in the book, it's negative 18, yeah.
18.
Negative, it's not negative 18. Are you sure it's negative 18? Why is it 2?
Yes, sir. Sorry. It's negative 18. Sorry.
Okay, this book made a mistake there. They put a 1 there. Yeah, it's negative 18, yeah, for sure. Okay. So what we actually done is, okay, we're not at the third order determinant yet. We're just doing these terms. But anyway, okay. Is there any questions before I'm going to conclude now? I'm just going to tell you, we're probably going to meet, I think, Friday evening again. We are gonna conclude this particular, yeah. Okay, cool. Is there any questions before I proceed?
So,
Yeah.
by the 3x3, do
Yes.
you use the signs only when they ask for the cofactor, or is it like just in 3x3 in general?
So it's in 3x3 in general, basically. So this is what I was talking about. Remember the thing I was showing you earlier on, that -1 plus, it basically comes down to that over there. So that is why knowing this, that thing is kind of useless, by the way. So that's important there. You asked a good question regarding when we evaluate the third order determinant, right? Basically, we can evaluate it with any element, which is a whole other story. But the idea is that you take, I'm going to explain this next time, so I don't want to confuse you. So you take the first element, right? I don't like why they do all of this stuff over here. So let me just use this one. Let me see what they're asking you. But are they expanding each row? Okay, here's row number 1. So you basically take the first element, right? There you find its cofactor, or the minor part, right? The reason why it's +1 because it's in the first, the first position. You come at the second one, it's 1. You do the elimination on the rows, and that's -1. That's why it's -1. Second position. And the third position over there's 5. You keep the 5, that will remain positive, as you can see there. And you obviously eliminate, and you're left with those elements. And then once you add all of them up, you've evaluated a third order determinant. Like I said, I don't know if I answered your question in terms of the signs. The reason why it's cool, the thing is you can evaluate the determinant even with the second row, even with the third row, even horizontal, vertically. You'll get exactly the same determinant, just by the way. So yeah, that's another thing which must be mentioned. Once we have the determinants, we come down to Kramer's law again, which is what I was doing. And it's a similar type procedure, right? So here they start with the 2x2, like we did already. And we'll come out to the 3x3 over here, which is over here. Same again, find delta 0, find delta x, find delta y, find delta z. Same concept. I'm not sure. I need to have a look at this, the way they get the determinants, but it's the same procedure. So can you see? It's the same thing when you're evaluating the third order determinant. It's all over there. I don't know if you guys can see that. Yeah. Whatever that is, I just mentioned. Okay, cool. Yeah. So, is there any questions before we conclude? Yeah. Before I close the session. It was a very long session. Jeez,
No,
man.
sir, I'm good. I'm good.
Okay. Perfect.
So, not a question on the session, but question on this assignment thingy next week, Wednesday, we having our assignment test.
Yeah.
Whatever they call it. Is the format like a question paper? Or, I don't understand how you can. Is it?
Yeah. So
Is the
Bianca,
assignment going to be like a question paper?
yes, exactly. Yes, it will be. I think the other tutors are busy preparing that now. So it'll be like a few questions you have to solve. You obviously have to scan it in and then send it to the tutor. You know what I mean? That kind of thing.
Okay.
It's not tough.
Okay.
Yeah, that is what I believe. Yes.
That's the one thing. The other thing is, I know the scope sheet, we're covering model 1, 2, and 5. I'm just concerned now with the time limit. Seeing that we're writing on or having to have our assignment on Wednesday.
So
to have a
do me a
session
favor,
on.
Bianca.
Yeah.
Send me a message. I'll ask the other tutors if there's enough time, because I know I think for you guys on the 12th, am I right?
Yeah.
Just send me a message. I'll forward it to them, and then we will decide.
Okay.
It might just be module 1 and module 2, which is not that enough.
Okay.
Yeah.
Okay. Thanks so much.
Cool. Anyone else?
So can you just share that conclusion that you guys come with in the group?
Oh yes, no, for sure. You'll know in the group. Yeah, don't worry. Yeah, I will send something there. You know what I mean? Focus on such module 1 and module 2, whatever.
Okay, perfect.
Okay, but what's key is if you go over the past paper, the textbook, the way they ask the questions is perfect. That's kind of the scope, what I believe the assignment will be. You know what I mean? Yeah, it's the same. But so guys, my plan is to meet you on Friday again, the same time, and we're gonna conclude this chapter. I'll decide if I'll meet you guys again.
So, do we need to put in our name, and is this like a register in the chat section? A name and student number, is this like a register and who's attending the class?
Yeah, so Microsoft Teams collates the register itself. So I have the tenants, so don't worry about that.
Okay.
Yeah, just worry about your preparation, and if you any questions, just ask us. That's basically it. And again, guys, what's important of this whole thing is like it's distance learning. You are studying by yourself. We're just here for support. I'm realizing now this book. Yeah. So I didn't teach this section last year, but like whatever works, you get the right answer, you stick to that. I mean, I know my approach is very concrete, but I have to adjust my approach to keep it to the book, just for the sake of lack of confusion. I don't make people confused there. I know some people haven't done maths in years, and so yeah.
Sorry, sir, I just have a question
Yes, go for it.
regarding the positions. So
Yes, yes.
if there's a number in the position, say there's a -6 in the position of a positive, do we ignore the negative of that 6 perhaps when we doing the cofactor?
So let me move quickly to it. Let me just quickly check. Let me go back up. Okay. Yeah. So go for it again. Sorry. You ignored.
I'm asking.
Yes.
If there's a -6 in the positive position, do we ignore the negative of the 6?
So what I mean is like if it's -6 over here, right? That's what you mean, right? Let's say in the positive position. It's basically -6 times +1. Are you with me? You don't ignore the negative. If it was over here, like -6, it would be -6 times -1. Therefore, it become +6. Are you with me?
Okay.
You got me?
Okay. Yeah.
Yeah. So you're not ignoring. It's like there's still a +1, there's still a -1. You know what I mean? You're just multiplying it. Yeah. So if it's -3 here, that's in the negative position. So that'll be a +3 over there. Like when you're doing this set of whatever. Yeah, the third order.
Okay, sir.
I think it's better that way you did, where you take that sign, you put it outside the bracket so that you know that it won't confuse you. Then you multiply by it when you are done. Yes, I think that way is better.
Yeah, that's. I mean, I've been teaching this for some time, so I know. So like again, even with the determinants of the second order, I find it a bit dangerous when people have to remember where to put stuff. Where if you have an approach on what to do, it's fairly simple. But like I said, whatever works for you. Because, I mean, I don't remember stuff to that detail. I just know, okay, eliminate, do that. I know why I'm eliminating. I know where it comes from. So like I said, whatever works, you do. It gives you the same answer. I will also do one more thing. Just tell me if you can see this. You guys have this calculator. Can you guys see my screen? Calculator should appear.
No, sir.
No, sir. Yeah, let me just share my screen again. Yeah. So this calculator is very useful. I did make another video. I'll probably share it again. Let me just quickly see. Am I sharing my screen now?
No, sir.
Okay, let me just see.
Nothing is showing.
Okay, cool. Don't worry now. Should be now. Yeah. Now?
Yes, sir.
Yes, sir.
No.
Okay,
Yes,
cool.
yes.
So if you have a shop, I recommend you let go. Divorce it, retrench it, whatever. Get this castle, this particular one. It's the white one. I don't know why. It shows that color. The other ones are the black one. So what's cool with this calculator, you're able to solve 2 by 2, 3 by 3. You know what I mean? Let me show you. I go to mode, I go to equation, right? What I'm going to do now, I'm going to solve this particular one on here, right? Watch this. So the first one, it's important you keep it in the form they want, which is the form which is given here, you know, x, y, the constant. I click one, all I'm going to do is populate the coefficients. I put in 3, I put in a 4, put in a 13, I put in a 2, I put in a -5, I put in a 1, and all I do is I press equal. X is 3, y is 1. You guys see that? I'm hearing nothing. Okay?
Yes.
Yes, sir.
Yeah.
Yes.
You can do something similar for a 3 by 3. You go to equation. You go to number 2 over there. Right? I'm just going to punch in random coefficients. If that's fine with you. If it's going to solve, because I mean, it has to make sense, you know. So I could be shooting myself in the foot here. So this is a good means of verification. I press equal. So my first value is -6. Second value is -10. And z is 20. At least that's been right. So can you see how powerful that is, right?
So will
Very
you
useful.
post the name of the calculator in the group, please? I see something
Yeah.
up top, RCFX, I don't know, but will you post it for us just to have it?
Just yeah, it's like it's pricey. It's like $700. Yeah,
Okay.
but it's a good investment. I'll show you this as well. And the way I'm promoting this thing is like I'm endorsed by this, and Cashflow should really endorse me. Even if you do complex numbers, right? You go mode number 2. You can type in complex numbers straight away. I'm going to show you this again if I'm doing complex numbers. Check there. Shift I. See there? So this is a good means of verification. It gives you peace. It'll also help you when you do electrodes N5. I press equal, it did that for me. You see there? I don't know if you guys done complex numbers yet. I'm also able to move from rectangular form into polar form if I need. Check it out. I don't know if you guys have done this. Who's here already?
Yeah.
Oh, I see this.
You started, so this is blowing my mind.
Yeah, there's a lot of things I can show you which can blow your mind. You can also do the determinant as well. Let me try to show you. Mode, what am I looking for? Matrix. So matrix, I'm declaring a matrix A. This is the size of the matrix. So let's say I want to find a determinant of a particular matrix, right? Let's quickly do a 2 by 2, right? Find 2 equations, 2 unknowns. Let me go to one of my determinant stuff. Why I'm showing you this is because in the calculator itself, right? This stuff is programmed in there. And so 3, 5, 4, -3. I'm doing this one over here. Can you guys see? Right? And then you press equal. Hey, am I pressing equal? What's happening? Oh, no. Okay, so yeah, so that's my matrix, right? That's fine. I press off. I go shift matrix. I press number 7 for determinant. Obviously, you can do this by yourself. I go shift matrix. My bad. Shift matrix. I press number 3. That's where I stored matrix A, and I press that, and my determinant is -29. You guys remember it being -29? You guys are saying nothing. Am I scaring you here?
Even this calculator needs to be studied.
Exactly. Yeah.
So,
So it's a good
doesn't
one.
the rules say no programmable calculator?
This is not programmable.
Okay.
I can show you what a programmable calculator uses. This is a calculator. That's what it is. It just has more functions. You understand? At the end of the day, guys, you're still gonna solve, you're still gonna present an analytical solution. Are you with me? It's a means of verification. Is that clear to everyone?
Yes, sir.
Yeah.
We must book a session to study the calculator.
Yeah, by then I won't be teaching you maths anymore. That's the thing. Yeah. I want to show you. I don't have 2 by 2 here. This is a different one, eh? Okay. So I'm just checking something. Okay, this is not what this is something else. This is even on Excel, you can solve determinants. Here's Brett. You got a question? I'll take Brett's question, then I'll end. He says it's fine. But anyway, you can do this on Excel as well. I've given my students an assignment like this before. But like I said, yeah, I'll retain my comments with certain stuff. But nevertheless, guys, I hope you learned something. Go over the third order so long. We'll go over it again. And we will continue with third order and then solve 3x3 equations. Yeah. Okay then. Cheers, guys. I'll see you Friday.
Thank you, sir.
Bye.
Sir,
Yes.
can you please remind us with this thing that you just did in the WhatsApp group so that we can pin it and just try it when we find a question more like this?